So in this video, we made our complete dashboard on Giga display to control my studio appliances and also to monitor real-time temperature and humidity sensors data on it. And all this is working over internet using Arduino IoT Cloud. So it's kind of a mini tablet that we can use to interact with our home and office appliances. And in this video, I'm gonna explain you each and every step to know how you can make it too. So let's get started with this video after a really short ad.
This video is sponsored by LTM, which is a PCB designer based software company. Now LTM is not just another PCB designing software, rather it's a world-class and award-winning PCB designing tool that has some features like advanced interactive routing with auto-completion, any angle routing, bus routing, phase and length tuning, follow me more and much more, which makes it an ideal choice for PCB designing by a lot of companies. Along with this, they do also have LTM 365 that not just covers the PCB designing part but also helps with design sharing via web, sharing designs to mechanical team for product design, centralized cloud storage and a lot more. And along with all this, they do have a very useful search engine made just for electronic components called as Octopart. Using Octopart, you can search for any components and you will be able to compare its price and availability around the globe. Not only that, you can also get the details about the components like its specifications and datasheet all at one single place. So LTM provides everything to make your production task a lot easier. So do try out all these services right now, as you'll be getting a free trial version by just clicking the link mentioned in the description. Happy making!
So this complete project is divided in 3 different steps. So the first step is we need to control all our home appliances using Arduino IoT Cloud. So we need to have a home automation project in between. Second step is we need to make a dashboard UI in which we can have different widgets for controlling appliances, controlling speed of fan and also monitoring sensors data. So we need to create a graphical user interface. And the third step is to link both of them, like the dashboard and the actual hardware that is controlling the appliances. So starting with the first part, then 2 months back I made a video about controlling your home appliances using Arduino Nano ESP32 and Arduino IoT Cloud, and in that video I covered each and every part, like how to make the hardware for that project, how to do coding for it, and how to configure the Arduino IoT Cloud as well. And after doing all this, we were successfully able to control up to 4 AC appliances, speed of 1 AC fan, and also monitoring temperature and humidity sensors data in real time on Arduino IoT Cloud. So do watch out that video, whose link is obviously in the description of this video. And with that, we have completed the first step of the project. Now let's move on to the second step. So now for the second part, we need the Giga display shield and we need to snap it with our Giga R1 Wi-Fi board. And with this, we are done with the hardware part, and now we need to move on to Arduino IDE to create the graphical user interface. Let me show you that process. So now here I won't explain you the complete code about how I made that complete dashboard. आपको समझ में भी नहीं आएगा शायद. But what I'll do is I'll rather explain you the process about how I made that complete dashboard. उससे ये फायदा होगा कि you will not only learn how I made this dashboard, how you can make this dashboard, but you will learn how to make any dashboard, how to add any widget, how to customize it, how to add the events to it. सब कुछ पता चल जाएगा. So let me show you that process. So first of all, this is the very basic example that is creating a grid object of the size display width display height, which is complete 800 by 480 pixels of grid, and here we can add any widget. Currently we haven't added any widget. So after having this sample sketch with you, you can go to the LVGL documentation page, whose link I'll be providing in the description of this video. And this is an amazing documentation, like you don't need anything else if you have this web page. Okay, you can go to the widget section, and here you can choose any of the widget. I will click on the button widget and I will click on the examples. Now here if I expand this C code, I will get a complete code for creating a button on my display. So it's a 2 different functions here. I'll quickly copy this code and I will paste it above my void setup. Now here, what is the purpose of 2 different functions? Well, one function is used for configuring that button. What will be its size, what will be its shape, where it will be placed, what should be its label. Everything will be written here inside the main configuration function. Then the event handler function is attached with the main function by adding this line called as add event. As you can see, the event handler is attached with our button 1, and this event handler is responsible for adding any kind of actions to our button. If you want to turn any LED using the button, we need to provide in the event handler. If you want to send any data to the cloud by pressing the button, we need to provide it in event handler. So that are the purposes of two different functions. And now to show this button to in our display, I just need to copy this main function and paste it just at the end of void setup inside void setup. So yeah, after pasting it, now I will select the write COM port and write board. And first let's just try to compile, but it won't compile. It will throw an error. Let's just wait for that error and I'll show you why it is coming and what's the solution of it. So as expected, we got an error called as lv_screen_active was not declared in the scope. Now, what is this error about? Well, it's the error of wrong syntax or wrong keyword that is not found in the library. And this error occurs when you copy the code for a different library version and inside your Arduino IDE, you have a different library version of LVGL I'm talking about. So first cross check that which library version of LVGL we have installed. For that, I'll go to Sketch into include library into manage libraries. Here I'll type out as LVGL, press enter. And here's the LVGL library version 8.3.6. Now I'll go back to the LVGL documentation and here I'll select the version 8.3.6 and now it will refresh the page and will provide us all the codes for that particular library version. And now if I go to the widgets and copy the button example code, which is provided here. So I'll copy both the example codes, both the functions. We'll paste them above the void setup as we did before. We'll copy this function and add it inside our void setup. And now if I hit the upload button, the code will get successfully compiled and it will get uploaded as well. So first, let's just observe how the code actually looks like in our screen. So I'll turn on my smartphone's camera. And here, as you can see, we got two buttons. One is labeled as button and other is labeled as toggle. Okay, and I can click both the buttons. Perfect. But we are not able to see any kind of response in the serial monitor. Let me just open it. If I click on the toggle button, nothing in the serial monitor. If I click on the button, no response in the serial monitor because we haven't added any kind of events yet. Now let me show you how to add events to this button widget using the event handler function. And also I'll show you how to customize this button. So first let me show you how to change the configurations of the button. So here we'll go to the LV example button_1 function. And here, as we have seen, there are two different kind of buttons displayed on our display. So I just changed that to only one single button. So I'll remove this many lines which will delete the button. Okay, so now we do have only one single button. Here you can change it in the label section. So here I can write as my button, and with this the name of the button displayed on the display will get changed. And next, if you want to change the position of the button, well, here you can do in the align function. So right now it is 0, -40 as respect to the center point of the display. So here I can change the position like 100 and -100. So X is 100 and Y is -100. Just a very random coordinates I have chosen, and you can choose any of the coordinates that you want. And that's how you can change the placement of the button. That's how the all the configurations are done. And now if I talk about how to do or perform some kind of task when the button is clicked, well, that is mentioned here inside the add event. So first of all, we need to provide an event handler function or attach an event handler function with our object, which is button. And inside that event handler function, we can provide the task that we want to perform. So if the button is clicked, let's just do a very simple task of printing on serial monitor as button click. Perfect. And we need to begin the serial monitor as well. And let me just hit the upload button. So with this, if I click the button, it will just print as button clicked, and also the position of the button is changed. And here, as I'm written as serial print, you can write any line of code that you want to perform when the button is clicked. The code is uploaded, and as you can see, the name of the button is changed to my button, and now we do have only one single button on the screen, and its position is also changed. And now if I open the serial monitor and let's just try to press the button, and as you can see, it says button clicked. So every time I press the button, it will just say that button clicked, and the touch is really smooth because it's a capacitive touch panel here. So yeah, that's how you can use the button widget. That's how you can use the event handler to do all the tasks. And that's how I use 4 different buttons for controlling 4 different appliances. Now let's move on to the next widget, which is to control the speed of the fan. So for that, I have used the roller widget here. So you can get the roller widget details here inside the roller section. Here, if I go to the example, like we'll be following the same process. I will teach you the process but how to use the widget. बाकी सब आप देख लोगे. So again here I'll open the C code, and here there are 3 different kind of rollers that they have shown, but we want only one single roller. So I will just copy this much line of code because the other 2 set of code is for the other 2 rollers. So I'll copy that and I'll again follow the same steps that I followed before. I'll first of all delete the button part, and I'll paste the roller part and close the function. Perfect. We got our roller function here, and we just need to copy this line of code and paste it here to showcase that roller in our display. Let's just hit the upload button and let's see if we get any error or not. Oh, we got the error, and it's about the font style. So here they are using kind of a font, but I don't find that kind of font inside this code, and also I tried to search for it online on different forums, but I didn't find the solution of it. So मुझे एक solution मिला. Just comment it out and hit the upload button. It works. Okay, so the code is successfully uploaded, and here on our screen we got a roller which I can slide up and down. So I can change the number up to 10, I guess. Yes, and I can scroll up to go to the number 1, and that's how you can use this kind of roller to control the speed of the fan, to select any option, any kind of thing. I personally used it for controlling the speed of the fan from speed 1 to speed 4, and also off position as well to turn off the fan. Now here again the steps are same. You can configure everything here. You can assign the task here, like you can configure how many steps you want by changing this number. You can configure its position by changing this. You can assign the add event, or we can say the callback function, using this add event function. So event handler is assigned, and whatever number is selected will be stored inside this character array buffer, and you can compare that number to do any kind of task, as I did for controlling the speed of the fan. Simple process, simple steps need to be followed for learning different widget, and that's how you can learn all the different widget, try out their sample codes and use it for your application, just like I used for my home automation project. Well, it was not easy task. It do require a lot of time, lot of efforts, lot of patience, and lot of configurations to build a dashboard like this. But eventually I made the complete dashboard, and I'll be providing its sample code to you so that you can use it for your reference, absolutely free of course, and make your own version of the home automation project. And that's how we completed the second part of this video, that is to build the GUI. And now we are left with the third and the most important part, which is to link our dashboard or our tablet and our home automation project using Arduino IoT Cloud. So let me show you that process as well. So for that, I'll go into my Arduino IoT Cloud and log into my account. Now, as you can see, I already have the Arduino Nano board already configured for my home automation project, and I do have all the variables like the relay, the temperature, humidity, fan, and all the things. And it is in working condition. As you can see, the status is currently online. I'll go back to the things, and let's just add another device, another thing, which is our Arduino GIGA R1 Wi-Fi board. So I'll click on the create button. Now, in my case, I already connected the GIGA R1 Wi-Fi board with my computer, and I already installed the Arduino create agent, which is running. Now I'll click on select device and click on set up a new device. It's a board from Arduino, so I'll select Arduino here, and now it will automatically recognize the board connected with it. Okay, so GIGA R1 found. I'll click on the configure button. Let's just keep the name as it is and click on the next button, and we are done adding the device. Click on the done button. So our device is successfully associated. Next step is to provide the network credentials. So I'll provide the SID name and password of my Wi-Fi router here. Perfect. Click on the save button, and now we need to add the variable. So click on add variable. Now here we'll be adding the same variable that we added for a home automation project. That means 4 relay variables, 2 variables for sensor, 1 temperature, 1 humidity, and 1 variable for fan speed control. So I'll quickly add them one by one. Okay, with this we successfully added all the cloud variables required for this project, and now we need to sync these variables with the variables already created for our home automation project running on the Arduino Nano board. And to do that, Arduino IoT Cloud has a very useful feature, and you can do this with a one single click. Let me show you how to sync 2 different variables from 2 different devices. So let's try out with the relay one. So I'll click on this cloud variable, click on edit variable, and here I'll click on sync with other things. Now here I will select the relay 1 variable from the Arduino Nano device or Arduino Nano thing, you can say. I'll click here, click on synchronize variable and just click on the save button. And now what will happen is whatever data is there inside the relay 1 variable of Arduino Nano, it will automatically sync with the relay 1 variable of our Arduino GIGA board. So if I click the button here and if I send the data, it will reflect in the Arduino Nano as well. And that's how you can sync all other variables to transfer the data to and fro between the things. So let me do the synchronization process for all other variables. And we are done. We have successfully synced all the variables for relays, fan and the sensors. And now if I go to the sketch portion, that it already created a sample sketch with all the cloud variables declared in the code. Now what we need to do is we need to club this IoT cloud based code with our code that we have created for creating all the graphical user interface. We just need to club them together, and I already did that, and let me show you that final code. So here is that final code, and here I already included the things properties.h header file that contains my SID name and password, all the cloud variables, and everything is declared here. And here in the main code I already provided all the functions required for the cloud variables. And now how I link the graphical user interface with the cloud section? Well, what I did here is if I take the example of a button, then inside the callback function of button, let me show you the example for button 1. So inside the button 1 event handler, that is the event handler for example button 1, what I did is as soon as the button is toggled, I'll print on the serial monitor as button 1 toggled, and also I'm toggling the relay 1 state, and relay 1 is nothing but the cloud variable. So what it will do is it will change the data on the relay 1 cloud variable of our Arduino GIGA board, which is synced with the Arduino Nano's variable, and ultimately it will turn on the light. And that's how I did for all the variables. And with this, we successfully made our graphical user interface based dashboard to control the appliances on the other device over internet using Arduino IoT Cloud. And now let me just try to upload this code and show you its practical working demo. So here is the complete dashboard that I made, and here on the top left corner I just added a label widget that contains the title of our project. And now let's see this in action. So here you can see I can easily control all the 4 lights using the button with a very low latency, and along with controlling them I can also control the speed of the fan from 25% to 100%. Also, we can visualize the current temperature and humidity sensors data on the meter widget along with their values at the bottom. And that is our own made kind of mini tablet to control and monitor your IoT devices. Well, do click the like button if you really like the project or at least got to learn something new from it. Also, do share this video with your friends whom you think should try their hands on with this project. We'll be providing all the codes required for it in our GitHub repository, whose link you can find in the description of this video. And yeah, that being said, I am just ending this video here and now. Just wait for my next video and then explore, learn, share with me, techiesms.